Okay, so my name is Katarzyna Orzechowska, and I have been working at ING Tech as a data scientist in a security field for about 4 years now.
And my name is Mariusz, and I'm working in Hunt Squad at TechPL at ING. And I'm mostly responsible for providing data platform for our data scientists. Today, we would like to show you how data scientists can cooperate with data engineers. So we would like to show you how to teach your data scientists to leverage the analytics platform. Let me do a short introduction. So I would like to tell you who we are. ING Group is a Dutch multinational banking and financial services corporation. ING is active in more than 40 countries at the moment. And this is quite important to understand our infrastructure. ING have multiple small companies inside the group. One of them is ING Tech Poland. We are responsible for providing IT services and operational services to whole ING Group. One of the global services that we are providing is IT security. This is the part what we are responsible for. We are the part of the Hunt team. Hunt team is one of the squad in the security area at TechPL. You need to know that our squad have a few small subgroups inside that team. I am the representative of platform engineering. So I'm the person who is responsible for providing the best technology to our data scientists. So I need to take a look at the data scientist needs, and I need to adjust the technologies, and I need to choose the best technologies for them. We have also, of course, we have a data scientist, so they are responsible for creating machine learning models. And hunters, that subgroup in our team is responsible for analyze the result of machine learning models created by data scientists, but also they are responsible for providing an input for these models. So we need to cooperate with each other.
Okay, so we are mostly self-sufficient as a team, and most of the applications run on our platform. So that means that we are able to do changes quickly and with minimal formalities. So the whole thing has access to most parts of the platform, and everyone is really encouraged to test stuff and try out, new things. So some of them will fail. That's okay. We can always switch to something different. And we actually found out over time that our roles blur a bit. So everyone is doing their a bit of maintenance work on the cluster, looking at data, or actually hunting for threats. And when we were starting out, we know that doing things you're not familiar with is difficult at first. But from our experience, we know that some data scientists or analysts prefer to do things in CSV files even now, like this cat here, because simply it's something that they know. So we encourage everyone we work with to step outside their comfort zone and try to do things a bit differently. So, okay.
Yeah, so we have a few challenges that we need to solve. So first of all, in security area, we have many users. So our platform needs to be ready to users with different level of skills can start working on it. Moreover, our platform needs to fulfill requirements of the high availability. So we need to be ready for any disaster recovery test and real failure that can happen in the architecture. We need to keep in mind that we are working on the critical data. So there is a lot of the extra security restriction. As I said at the beginning, we are multi-region company, and I need to mention that it's quite hard for us to put our data in public cloud. So in most cases, we are obligated to use our on-premise infrastructure, and additional requirements is that in some countries there are specific regulations that doesn't allow us to send this data abroad, so data needs to stay in that particular country. Another requirement for us is to have a possibility to scale up our infrastructure easily without interrupting the users that are working on our platform. We would like to use frameworks instead of pure containers, because in that way of working, we can just easily create all of the relation between the containers, including rolling update, but also something that should be picked up during the container failures, or something that should be done whenever, for example, we are trying to scale up our infrastructure. Maybe data should be automatically relocated. We need to be sure that we have a full data integrity and delivery guarantee. Yeah. Each single event is important for us, so we need to be sure that we have everything. And as I said, multiple regions, so we need to have a possibility to start our task on any regions at any time. So our platform, which is called Security Analytics Platform, at the moment is responsible for handling the more than 75,000 different sources of the data. By sources of the data, I mean the logs from almost all application, all important applications that we have, operating system, databases, network devices, middleware. So all of this data needs to be transported to our platform, or to this dedicated, let's say, let's call them silos. At the moment, we have more than 200,000 events per second. So yeah, it's quite huge number. So we need to be able to handle that. But if you would like to check what is the daily size of the events, it's more or less 13 terabytes of the data. So yeah, this is something what we have right now. If you would like to take a look at our infrastructure, so this is the general overview. So we are sending all of the data that we have to Kafka. So in our case, Kafka is some kind of event bus. We choose Kafka for two reasons. We can easily use Kafka as a buffer, and we can subscribe our topic with using two different consumers that can consume the same data for completely different purpose. As a persistent storage, we choose S3 solution. This is the consequence of our infrastructure. As I said, we have a multi-region environment that needs to be started on premise. So we have our internal S3 solution based on the CEF product. For the short-term storage, we are using Elasticsearch just for the indexing quick search. And this is one of the most common solutions. On our platform, we are using as a resource manager, Mesos. And on the top of the Mesos, we are starting our services. With that way, we have a possibility to get an access to our data in interactive mode or in batch mode.
Okay, so onto the use case. SOCs, Security Operations Centers, use CM solutions to gather and monitor events happening on their infrastructure. In our case, it's ArcSight, but it's actually a rule-based system, so a long set of if statements. So for example, if you want to be alerted then that a user tries to log into an account more than 20 times within 1 minute, it might indicate that someone wants to brute force a password. So this rule can be implemented in a CM system. But it's actually pretty limited. Not everything can be implemented there. Some events events can be correlated only within a short specified time frame. We also do have to remember that it's not a big data solution, so it's not prepared to handle the increasing amount of data. Okay, so we have all this data, and we thought, hey, let's do something cool with it. We tried to take a look at them and try to find some anomalies within the data. So this is just a simple overview of what we were trying to do. You have all these obviously fake data and all these events that were triggered by Adam, and we see one event that was triggered by Klaus. So in this context, this event is an anomaly, and it's something that a security analyst might be interested in. So we have we wanted the framework to be universal. So if you wanted in the future to add proxy data or NetFlow data to it, it should be possible. We also wanted to recalculate the baseline every specified period of time, and we wanted the solution to be scalable. So on to the implementation. As a data scientist, the first thing we do is look at the data, and the data was not good. So there's this thing called CEF, which stands for Common Event Format. And what it actually means is that you can have anything in any column. And of course, there's also the sheer amount of data we have. So we have over 500 million events per month in almost 400 columns. And what it means that data is actually pretty inconsistent across the vendors. So in the same column, you can have a string, a bool, and a timestamp. It really doesn't make any sense for us. So what we found is actually that data is pretty consistent within something called a trio. And a trio is a set of device vendor, device product, and name column, which actually represents an event that was triggered by a specific action within an application. So, okay, we have 400 columns. How to, we do not want to create a baseline on all of them. We just want the important ones. So we thought, hey, let's not take columns that all have different values because they are useless. For example, timestamp. We will, of course, disregard empty columns, and what's left and what's good, we will keep. And it actually, we actually have the longest set of columns we have is 34. So we went from 400 to 34 columns. And within our infrastructure, we have almost 3,000 distinct trios. So distinct sets of device vendor, device product, and name. This is what the finished baseline looks like, a part of it. So basically each value in a column is scored, and this baseline is stored in our database. In this case, is S3. So we tried to run it with Spark, reading data from S3, and it didn't work. For one app, for 1 day of data, it took 7 minutes. So if you wanted to do the same thing for just 1,000 apps for over a period of 30 days, it was run for 145 days, which was, not ideal. So this is the part where our engineers come in, with their fancy technologies. And our team actually does a lot of proof of concepts and testing. So sometimes we as data scientists are a bit overwhelmed with the amount of information where, Mariusz is like, hey, there's this cool new distributed big data synergy solution that's in cloud, try it out. So it might be a bit too much at times, but in this case, they actually came to us with Alluxio and Presto, and turns out that it was actually exactly what we were looking for. So we ran the same query, but this time it was reading data from Alluxio and not S3. And the same query took only 24 seconds. So, the gain is huge. This is actually how it looks in our code. What it does is you take data the trios data frame, you turn it into RDD and you send it to executors. And each executor queries Presto for the significant columns. And then, the data goes back to Spark driver. So in our case, we run Spark on 5 executors, and you can see 5 concurrent queries that are in Presto. So that's pretty cool. And in the end, a set of 1,000 columns ran for 4 hours. So, it's great. We're really happy. It was a good day. And just for the purpose of this presentation, I ran the same code, but instead of Alluxio, I read S3. So the queries were going from Presto to S3. And it ran for 3 days. So you can see just what Alluxio can do to you. This is the whole framework with how it looks on a cluster. In the heart of it is a Faust streaming job. Faust is a streaming framework that allows you to have these distributed string pipelines. So it takes the baseline from Redis, takes data from Kafka, scores the events, and sends it back to Kafka, basically. Okay, so
yeah, one remark here. As you can see, at the bottom we are using Alluxio and S3. So it's working in that way that we have async true modes configured on the top of the Alluxio. So whenever we are saving the data in Alluxio, then we are getting the write with memory speed. And somewhere at the bottom, we have there is a job responsible for synchronization with the S3. So it's really cool for the data scientist because they can easily create the baseline and create the flows whenever they want. And of course, we can still have a copy of this on the S3. Okay, so that solution was really easy to implement because first of all, data scientists don't need to change the code at all. They need to only point to the different location. So they need to only use Alluxio path instead of S3. So that is a huge benefit. However, right now we would like to improve another things on our platform, because we can see that we have a lot of the users that are responsible for creating reports. So they are creating a simple query, and after all, they would like to save the result on the S3. That operation is not so perfect. Saving the data on the S3 is quite slowly, especially when you're creating the huge report. So we would like to use the catalog functionality and use Alluxio as a main storage. So the goal of our platform is to use Alluxio as a main proxy for our data. So it doesn't matter what you would like to have at the bottom. All of the data should go via Alluxio. So right now we are in the POC phase. Our power user on the platform have already possibility to do that. We don't have any problem with that part, so we are really happy. Another thing is transformation service. As we mentioned at the beginning, we have a lot of the events per second, and we would like to have it on our platform as soon as possible. So at the end, we will get 100,000 objects created on our platform. It's not so perfect from the performance point of view, because you need to establish as many connections to the S3 as you have objects. So this can take a while. So to solve that issue, we need to create a merging job that job needs maintenance. And right now we have a transformation service that can help in that case. So right now we have a huge POC also related with that part.
Okay, and just to add, we are still looking at using Druid in the ingestion phase of our work. So I think it might help us with the amount of data, turning it into actually something actually usable. Okay, so for me as a data scientist, I think the biggest thing is being involved in the implementation of some technology and testing process from the beginning. I feel like it's it's time that we are all getting to know the technology, and they as engineers benefit from the feedback we provide, and we are more familiar with the way stuff works. So it's not a black box for us anymore. Also in pre-COVID times, we used to sit right next to each other, and we all know that working with someone who you drink coffee with, it's much easier than creating new tickets and waiting for someone to get back to you eventually. It also means that we have access to almost everything, which might sound bad, but and sometimes we do mess things up a bit. But the upside is that we are much more self-reliant and comfortable with the engineering part of our jobs. And we often deploy and test stuff ourselves, so we don't have to bother the engineers.
And from my point of view, it's really important to have open communication with the vendors. So if there is a possibility to discuss with the vendors and present to the vendors our needs and expectation, it's really useful. Yeah, because we need to keep in mind that at the end we would like to achieve exactly the same goals. Vendors would like to deliver the best product as he could, and we would like to consume the best product as we can. So at the end, we have exactly the same goal. So it's really important to have a really good cooperation with vendors. And something that is maybe not so obvious, but something that we are using really often is informal communication channel. If you have a possibility to contact with the engineers from another company, discuss about the issues, discuss about the problems, about challenges, then having something like that in place is really useful.
And that's it. Thank you very much.